Hello guys, welcome back to the TS Master tutorial series. My name is Ali Feidi, an ADAS control engineer here at Software Motion Company. In the previous session we talked about CAN statistics window and how we can check the communication health over CAN, and in this very important session we are going to talk about the visualization tools in the TS Master and how we can observe different signals in order to analyze and debug them. We debug our modules, and we have a different ways in order to track the signals. But we are going to talk about the graphics window here at data analysis section in the analysis section in ribbon toolbar, and also we are going to talk about the gauges, two very important window in TS Master, and very powerful and important. I have to mention that before recording the session I have uploaded the DBC file, and also I have uploaded my BLF file in order to plot the different signals in TS Master. First thing that we need to do is click on Start Operation in order to connect all the logical channels of the software to the hardware channels that we previously set them. Here I click on the Start. As you can see in the system management, you can see application connected. It means that right now we can see all the signals over the CAN. So after that I wanna go to the bus replay and replay my BLF file. And in order to check your connection, you can see a trace window that we previously talked about. You can see we are transmitting and receiving all the messages, and everything about the communication is fine. After that, we go to the graphic window here and click on graphics. As you can see, this window that I already opened it. Here you can add different signal from your DBC file and you can monitor them. For example, when you right click here, you can see the CAN signal, link signal, flex array signal, Ethernet signal, system variable signal. All of these can be seen here. It defines on your communication and where you wanna look and track your specific signal. Here I work with CAN, so I click add CAN signal. As you can see, I can, based on the DBC file that I previously uploaded, I can search for a specific signal. Let's import vehicle signal here. After importing the vehicle signals here, you can see the signal can be tracked here. Let's talk about the toolbar here. This is pause and play signal here. As you can see, now I play it. I can see the signals is changing over time. As you can see here, the vertical axis is the value of the specific signal based on the unit that is designed in the DBC file of that specific signal. And also you can click here in order to see the vertical axis. Also we will talk about it more in detail. You can check change the color of that specific signal. For example, you imported many signals, but you are looking for a specific signal in order to find out which problem the project has. This changing color can be very useful. Another thing is type, which CAN you are receiving, or sometimes you receive from as a system variable. Also it can be link communication. Here you can find it out. Also the name of the specific signal that is previously defined in the DBC file, the real-time value of that signal that is changing, as you can see over time. For example, here we have 0 vehicle speed, and this value, as you can see, change here. Also you can import another signals in the DBC file. Let me search the yaw rate here and apply it. You can see by clicking on them and clicking on this checkbox, we can see yaw rate here. Whenever you click on it and you click here, you can see that this is a single signal mode, and you see just this signal. By clicking on it, you can put your cursor here and there see the real-time value, and this is the vertical value of, this is the second, based on the second and based on degree per second, for example, for your right here. But whenever you click on multiple signal mode, you can see both signals at one specific plot here. Also, you can by right click here and choose increment split, you can add another session and add some signals. Click on add can signals. Here I can for example ADAS FCW status, and I click this checkbox in order to see the units of that signal in the vertical axis. And also, when you make another group, you can change the name in order to be more sort out. For example, I changed it in CAN information, and I changed this group name to ADAS information, for example. By right click on it and click on distribute split, you can merge these two signals and sections. Another thing that I really want to talk about is these option sections. In order to export your data and the signals in the CSV file or any other file, you should be in offline mode. As you can see, I'm right now in online mode and I cannot export them. You can add increment split and discriminate split. As I already mentioned, you can go to the x-axis mode and click on it, start from the top, and as you can see, these values, x values is set, and you can track them sometimes easily, but I personally prefer integral mode. Also, for y-axis mode, you can click on separate axis. You can see you have this section separately, and this configuration is based your opinion. Also, in the view we have scroll up, scroll down. I think it's obvious. What does it zoom in, zoom out, toggle legend, toggle absolute line. All of this is very important and can be manually defined. Also, by right clicking here at any group and section, you can delete the signal that you previously selected, or you can clear all the signal and change and import them from the beginning. And one thing that is very important, whenever you select a signal and click here on edit signal, you can see the features of that specific signal. For example, minimum and maximum value of that signals, the byte order, value type, unit factor, offset, initial value, and other features of that specific signal, which is all of these properties are defined in the DVC file. Let's add another section and also rename it as ADAS information. Number 2, I'm going to add CAN signals here. Previously, I have uploaded the imported FCW set, so now I'm going to add LLP status because I have these in my BLF file and can be seen here. As you can see, for example, these two are passive right now, and based on the situation that car is in, can be another mode. Let's discriminate this split. Whenever you click on this distribute split, you get a little sort out, and let's change the view to y-axis mode too. In the y-axis also you can for example set a fixed minimum and maximum value in order to be more convenient to follow. Also, whenever you click on it, it gets more pointed out, and you can see them sometimes easily. Let's a little zoom in here. By clicking on clear all data, you can delete all the signals that you can right now see here and start from the beginning. For example, you want to clear all the signal data. When you click, we can start over again. see the signals. Let's discriminate this specific signal. Yeah, I think this is all you need in the TS Master in order to track the signals in the graphic window. Now that we learned almost a lot of things about the graphics window in the TS Master tutorial series, let's move on by learning about the meter window. In order to open the meter window, you should go to the data analysis section in the analysis ribbon toolbar and clicking here and click on add meter, or as you can see, I previously opened a window in order to see the signals. There is a difference between tracking a scene signal in the graphics and the gauges. In the graphics, you can track the signals over time, but we use gauges in order to quickly see the value of the specific signals immediately. Let's open again by right clicking on the empty place in the meter window and click on add can signals. When I click here, let's again import the vehicle speed from the can. As you can see, there is a dashboard style signals here that you can see minimum maximum value. When you click on it, you can see the property of the specific node that it previously defined in the DBC file. In order to set as your comfort, you can change the UI size based on that you want. For example, let's make it a little bigger, as you can see. Also, you can change the type that you want to. For example, this is circular. You can change it to circular and half this way, and in other features, recorder, maybe digital, maybe linear. But I personally prefer circular way, which is more convenient to see. Also, by right clicking on empty space, you can go to the select style and choose the way you want to that gauge visualization be. For example, let's click on classic here, click. We can see that is the style is changed, and you can choose the wherever you want. This is totally based on your preference and the way you want to these gauges be. Also, you can see another example that we have was a yaw rate. You can see add your yaw rate here by clicking right there. Let's, for example, I don't know, 40 and 600 and 400 here by applying it. You can see, but let's change it to the digital way. After setting up this configuration and finding it out, I replay my build file and go to the meter. As you can see, you can in this cell you can follow the value of the specific signal immediately, and also you can see here that is in the dashboard as well how it changes as the times go by. The changes can be seen here. It's very great to see the vehicle speed as it is like the cluster in the real vehicle. Thank you so much for watching this video. This session was about the visualization tools in TS Master. Next session we are going to about the hill test, hardware in the loop, and deep more in the detail of CAN communication. Thank you so much for your watching.